Hello everyone, my name is Abhishek and welcome back to my channel. Just imagine this. You run a kubectl command. Kubectl creates an image for you. Within the image, you can see the traffic flow to the pod. I mean, when user tries to access an application, how user's request would go to an ingress. From there, how would it go to the right service? And finally, how would it go to the right pod? What is the status of the pod? What is the status of the ingress? What if you can see all of this in a single image? I know kubectl does not support this today, but we can do this with the help of AI. I posted a couple of days ago on LinkedIn that I'm creating some cool project like this, a hobby project, and a lot of you are interested in it. And then I thought, why not we all implement this within our organization? Because kubectl is something everyone use on day-to-day basis. In today's video, I'll explain the high-level architecture of this kubectl plugin, and then I'll also show you live how this plugin actually works and how it can generate the image that I just mentioned. This is a very simple project. Don't think this is a complex one. This is absolutely beginner level project, and you can do the same thing in next 30 minutes after watching the video. So without any delay, let's get started. First of all, how does this actually work? Very simple. As first step, DevOps engineers would create a kubectl plugin. The kubectl plugin would take three parameters as input. First one is the name of the pod. Second one is the namespace of the pod. And then the location where the generated image would be saved. It can be the downloads folder. It can be the temp folder. Users provide the location and kubectl plugin would save the image to that location. But Abhishek, how does the image gets generated? This is exactly where the kubectl plugin takes the help of AI. It can be written in Python. It can be written in Golang. In our case, we are using Python to write the kubectl plugin. Now within the Python script, we will make AI API calls to generate the image. In fact, we will be using two different API keys here. One, we would be using the Luma UNI-1 API key, and other, we would be using the OpenAI API key. But Abhishek, why would we need two different models? So the OpenAI model, the API key that we are going to use, basically takes the pod name as input from the user. It analyzes the Kubernetes cluster and it defines the relationship. Ingress is connected to service, service is connected to pod, what is the status of the pod, and this will create a very detailed prompt. Now using this prompt, the Python script would make API call to the Luma UNI-1 API. Now this API is very good at image generation. In fact, this is the one that is generating the image for us. But Abhishek, why not use OpenAI for generating image as well? You can try that, but OpenAI is not very good at image generation. And it is also quite expensive when it comes to image generation. Luma UNI-1 API is known for image generation. It can generate quality images for you, reliable, and this is also known model for image generation. So it is less expensive for you, right? So we are using two different AI API keys here. The first one, we are using OpenAI API key. This will generate the relationship between ingress, service, pod. It will generate a detailed prompt. And this prompt, using the Python script, again in the kubectl plugin, will make an API key with Luma UNI-1 API. And this will generate the image for us. Abhishek, how do I generate the API key for Luma UNI-1? Very simple. Just head to the Luma official website. You will find Get API option. And once you are here, you will get the platform.lumalabs.ai. Here, you can just head to the API option and you can create your first API key. And you can also go to the playground, write a prompt and see how the curl command is generated. This is just for your reference. If you are getting started, you can write some prompt. You can get the curl command and you can also try it from your local terminal. using the curl command. But we don't have to do it for this project. For this project, we are already doing it in the Python script. Perfect. Let me explain the flow one more time because this is very important. First, the kubectl plugin will be developed by DevOps engineers. The kubectl plugin takes three parameters as input: name of the pod, namespace of the pod, and location where the image has to be saved. In future enhancements, we can also make this location Google Drive location or S3 bucket location, anything. But right now, it only supports the local directory locations. Once these inputs are taken, the Python script, the kubectl plugin that we wrote, it makes two API calls. The first API call is made to OpenAI. Why? OpenAI analyzes the cluster, it gets the information of pod, services, ingress, and it establishes a relation, creates a prompt. Now, this detailed prompt is sent to Luma UNI-1 API key or API, and this will take care of generating the image for us. And this is the image that gets saved in the location. Now, looking at this image, anyone can understand what is the traffic flow to the pod. It can be developers, it can be testers. Just give them access to the kubectl plugin. Perfect. Now let me quickly show you how did I actually write this. In fact, this is very simple. Even if you are not good at Python scripting or Golang, you can actually write this in less than 30 minutes. I mean, you already have a reference. You can take this reference and you can write it, or you can reuse the same thing. So you can just go to this one, kubectl pod topology. I wrote this in Python. How this works, the execution goes to main. So this is the main definition or main function. So here first it accepts the parameters, whatever we discussed, name of the pod, namespace, and location where the image has to be saved. Once this is taken, it validates the API key, the OpenAI API key. It gathers the cluster resources, the same thing that I explained. It analyzes the user traffic flow. Once it gets the traffic flow, then it makes the API call to Luma UNI-1 API and image is generated for you. In fact, you can scroll up, you can look at individual functions and you can understand how the image is generated. You can see here how the system prompt is prepared. This is the prompt that is prepared. And if you scroll down, this is the function that is generating the image for us. And to install this plugin, okay, you wrote the Python script. Now you have to install. You just need to run this install.sh. Again, this is very straightforward. What this would do, this would bundle the Python package and this would add the Python package to the path. Once this is added to path, kubectl takes the responsibility. So when you run this binary or when you run this Python executable, kubectl would identify it and it would execute it on your behalf, right? So this is as simple as that. And finally, you just have to head to .env.local. I can't show you this for security reasons. I have my OpenAI key and Luma key here. Instead, I'll show you an example. So this is how you add your OpenAI key and Luma API key. Just add your values here and that's it. You are good to get started. Now let me show you. I have a cluster locally. I'll take my terminal. So this is my terminal. Let me switch to the folder. So pod topology image generator. This is the name of the application. I have a Kubernetes cluster. Let me run kubectl get namespace. So these are the different namespaces as you can see. And if I just run kubectl get pods, there you go. Nginx topology pod is here. How did I run this? In the Visual Studio Code, I already have the nginx topology.yaml. This is the deployment, this is the service, and this is the ingress. So I just executed kubectl apply -f nginx topology.yaml. Perfect. So this is the nginx pod. Similarly, you can see kubectl get svc, kubectl get ing. If you want, you can try it with gateway API as well. Okay. Now, because you know Nginx pod is installed using this YAML, you already know the relation. But this is the command kubectl pod topology followed by name of the pod, namespace, and location where the image has to be saved. This is the same location where I have my source code. And you can see right now there is no image here. But as soon as I run this command, so it it is analyzing the traffic flow and it got the complete traffic details. You can see name of the pod, name of the service, and it is waiting for Luma to render the image. That means it has already sent the API request to Luma. So it is working as expected. Let's wait for less than 30 seconds and we should have the image here. Okay. I'll also open source this repository. After watching the video, if you are interested, you can also try it at your end. I'll share all the relevant links in the description. And most of the information is available in the README file. So this is a README file where you can see steps to install the plugin and steps to use the plugin as well. Looks like the image is generated. Let me go back. Perfect. This is the topology image. I can see it here as well. And there you go. Very detailed image. Kubernetes pod topology from internet. Request goes to the Nginx topology. This is the ingress. It says no TLS. So there is no TLS here. This is a HTTP ingress. Request goes to the service. And from there, request goes to the pod. It also shows the service. So the pod status is in the running state. You can see the green icon here. And these are the different pod statuses. If the pod is in crash loop backoff, you would have seen this red color icon here or the symbol here. Perfect. So this way you can generate the image using kubectl plugin. As an extension, let's say you are working and using this in your enterprise. Instead of the local location, you can extend this Python plugin to store the image in an S3 bucket or maybe store it in a Google Drive. Any location where the employees of your organization can access. Once you create this plugin, you can share this access with your testing team or engineering team as well. I hope you found this video insightful. A lot of times we want to use AI, but we are not really very sure where to use AI as DevOps instance. You can come up with such cool ideas and you can use AI as part of Kubernetes, Terraform. In future, I'll make more videos on AI DevOps. Just comment on and let me know how useful you find this project. See you all in the next video. Take care.